Next speaker is Satoshi Miyazaki, the new director of the Subaru telescope, and he will talk to us about his observatory. So Satoshi, all yours.
Good morning. I'm Satoshi Miyazaki, and I'm actually interim director for the initial 6 months. So I'm being tested. And today I'm going to talk about Subaru's recent update. I only have 3 topics today because time is limited. First is Hypers Prime Count, which is wide field camera on Subaru survey status. And the second is going to be progress of the prime focus spectrograph, which you might be interested in. And the third one is the future, further future instrument, Ultimate Subaru, which is a GRL wide near IR imager, whose field of view is going to be 14 arc minutes times 14 arc minutes, which is very, very challenging. Okay, so first, let me show you where our HSC's SSP survey is laid out. SSP stands for Subaru Strategic Program, and we initially allocated 300 nights over the 5 years, but it ended up with 330 nights over the maybe 7 years, because during the course of the observation we have awful weather, so we requested 30 additional nights, and we ended up with 30 in total. So here's the diagram which shows you the area of versus limiting magnitude. So as all of you know, this diagram, there's some, if you have some limited resources, there's some sequence along this line, and CFHG legacy survey is somewhere located here, and HSC survey is slightly deeper and a little bit wider. And of course, we have LSST is coming in a few years, so we are somewhere in between LSST and your CFHG legacy survey. So this is our plan. We are trying to cover 12 square degrees, 1,200 square degrees in wide area, and deep 28 and ultra deep 3 square degrees. So this is originally a 3-tier survey, and we actually finished it. So on March 2014, HSC SSP started, and the last observing night was January this year. So it's end. And let me show you how the image looks like compared with legacy survey. Let me share my screen. Okay, this is part of the sky, and on the left, we have a wide image from the HSSSP, and on the right, this comes from the CFH legacy survey on the same area. So this is in the area of 2-hour field SXDS, and here is a wide area depth. And surprisingly, I think the CFH has a superb image quality, which is almost equivalent with our Subaru, thanks to the Marquet thing. And so this is, I think, the difference of the depths. So that you can imagine how our image looks like. And basically, this image is made public, and you can browse through this web page, HSC map, and you can just Google HSC map to reach this page. And most of the observing field is located on the equator. Some part is covered on the northern sky in order to collaborate with the hectomap, the Margaret Gerhardt CFA scientist. But anyway, so this is how it looks like. And let me bring this back to my original slide. Okay. So as I said, 1200 square degrees covered, and this is the final footprint. Some are left, unfortunately, and it's not perfectly or square, but I hope this can be called as a legacy footprint. Maybe if we have a few nights, we can easily cover this, but weather was not on site. So regionally, we are trying to cover, this is wrong, 1200 square degrees, but now we ended up with 11. So it's almost, and observing night was 300 to 330 actually. And now we are working on the final data analysis for this entire data sets. It's not the final product is still not available even within the collaboration, and maybe it's going to take another few months to get the data, the reduced data. But I think there's some prospect from our data set. This is one example of our result from a part of the 1/8 of the entire data set, 137 square degrees, which is collected within the beginning of the survey. And this is a comparison with other, cosmology survey, cosmic shield surveys. And, if you compare with the DES, with their 1800 square degrees data sets, that was like 2018. I think it was four years ago, so it's old, but but still, this gives you the difference between the DES data set and the HSC. I think the field coverage is smaller here at HSC, but the constraints on the cosmological parameter is almost equivalent. This is thanks to the depth of the HSC data, because the number of usable galaxies for lensing analysis is almost comparable, even if the width is narrower. So this is some sort of the feature of HSC survey, and I hope that because this data depends on only 1/8 of the entire survey, our sort of donuts shrinks more. And hopefully, we can say something on the cosmology in the coming, few months. This is the expected size of the donuts at the end. All right, so some of you might be interested in the data release from the HSC SSB, and final one, we are still waiting for it. And but the first weak lensing data is already, available to public. I mean, the first one is based. Our initial data was the first weak lensing catalog, and some of you might already play with it. And but still, as I said, we are still waiting for the final data release, internal data release. It's going to be summer 2022. It's something like that. And after maybe 1.5 years after, this data is going to be public. So it's going to be sometime in 2024 for this public data release. Okay, let me move on to the prime focus spectrograph. So basically, the prime focus spectrograph use the same wide field collector with hyperspectral prime cam and covered almost equivalent size of field of view. So although it's a little bit, hectagonal. And the feature of the PFS is the wide wavelength coverage. This is, because we have an infrared camera, but so PFS covers from 380 through 1260 nanometer once with a 3 camera. I think this is a unique, one of the unique features of the PFS.
Having those hardware and software components already at the observatory, we recently started so-called commissioning.
Oh, somebody is selling. Oh, okay.
Test the PFS.
Sorry, I didn't realize that there's a recording.
We did this twice so far in September and November last year, and we made various great progresses. What's presented at the bottom left is the spectral image of the sky on the spectral detector after 1,000 second exposure. In the middle, the good performance of the fiber positioners is presented as a color-coded plot of residual distances of the fiber.
You know what happened? The PFS project manager gave me a slide, but I didn't know that that comes with the the audio. So I think I hope that audio tells you what. I mean, there was a test observing run, but let me get back to that later. So this is a PFS component. There's a positioners, and the actual spectra is located on above the Nasmith floors. We put another new floor for this for gigantic spectra and fibers, of course, from top to this spectra. And
2 minutes left, Satoshi.
Yes. Okay. Sorry.
2 minutes left.
Oh, okay, 2 minutes left. Okay. Okay, so out of 4, 1 spectra is already ready. The cable is, one of the cable is already installed, and methodology camera, and also, of course, last year the big event had happened. Finally, the prime focus instrument, which has a Cobra module, higher positioner. This is the heart of this instrument one, and arrived and being tested now on Sky. So this is a sort of a project schedule. So we hope that the final components arrive next April. I mean, the number for spectra and camera. And then there's some events between, I mean, the, testing and things. And hopefully we start the science observation from the S24A. So this is, I think, the official schedule right now. So 24A, we hope we start the PFS observation. And finally, the ultimate is basically GLAO assisted wide field near infrared instrument covering up to 24 diameter of 20 arcs, which is, I think, very challenging. And they are working on it. And good news is that some of the budget is approved by the government, and which is being used to procure the other adaptive secondary mirror from Italian company like ISO. And so I think we have a very nice partner at ANU, the Australian National Universities, and they are building a part of the front sensor, although not all the fund is secured yet. We only have a budget for the part of the adaptive secondary mirror. And as for the instrument, the project is trying to build a large wide field imager, not the spectrograph primarily. But before the big one comes, we would be used the existing instrument MOEX, which is the field cover is limited for arc minutes times 7 arc minutes, but it has a most multi-object spectral capability. So I think it's much more versatile than this wide field imager. So while we are waiting for the development of the wide field imager, we will make full use of this MOX instrument, which is still very powerful and unique at Subaru. So this is a sort of project status, and they try to finish by the end of fiscal year 2028 and start the production from 29A, so 5 years from now. No, more. Sorry. So it's a big project. So this is a summary. It's just SSP observing completed, and data, all the data will be available to public in 1.5 years in short test case. And the PFS is likely to start the observation from S28, nearly fully funded. Commissioning observation started last fall, and remaining hardware is coming. And Ultimate Subaru GLO partially funded. I mean, yes, and observing with MOX, the specs here, will start from S29A. Thank you very much.
Thank you. Thank you, Satoshi. Any questions? Questions from the web? Oh, yes, Jean-Charles.
Jean-Charles speaking here. So good talk, Satoshi. I was wondering about the future of HSC once PFS comes online.
Well, although I became an interim director, I have some secret hobby, and I'm still working on the instrumentation, which is high-speed CMOS. And prototype has been already ready, and it can be that like 10 Hertz. But the disadvantage of still is that thickness of the depletion layer. It's like 15 micrometer thick. So we are trying to improve it up to like 100. And that is, if 100 meter thickness CMOS is available, then I will try to get the big money to replace the entire array to the CMOS. But the biggest question is, what do we do using such a high-speed instrument? So in order to explore such a unexplored parameter space, we will use retired sprime cam and to make a high-speed old sprime cam, and to see what we're going to see. And that's my personal plan, and it's not completely approved. So this is not an official statement from Subaru. So don't take this so serious.
Okay, thank you. Let's thank Satoshi again.